Professor Bialis here. In this video, we are going to be covering section 10.6, where we solve radical equations and problem solving. Now the problem solving part, again, is just word problems. And in this case, the word problems are actually going to be a lot easier than the word problems we've seen in the past. They're not going to be just random scenarios where we have to construct our own equation. They're either going to be, here's a formula, plug and chug, or have some sort of application involving the Pythagorean theorem. So it's going to be very structured either way it's presented to us. But before we get into the word problems, let's talk about the equation solving portion of this. So let's just jump right into some examples and see how they play out. So let's say we want to solve the square root of 3x minus 2 equals 4. Okay? Now, first thing we would do in any of these equations is get the radical isolated on one side, which it is in this case. So that's done for us. Now, remember with fractions, what you multiply the bottom by, you multiply the top. In equations, it's a similar rule, but it's much broader. Anything you do to one side, you can do as long as you do it to the other. So what you do to one side, you do to the other, but it's anything. Add, subtract, multiply, divide, or even, in this case, square. Squaring a square root eliminates it, and all that happens is that the radicand drops out. And look at how nice of an equation we end up with. Okay, now it's just back to normal equation solving. So I'm going to add that 2. And then divide by 3. And we get x equals 6. Okay, now here's something I want you to write down and remember. Always check your answers to a radical equation. Always check the answers to a radical equation. The reason being is that sometimes you do everything right and the answer is just a bogus answer. Okay, let's check this and then I'll talk more about that. Now when we check, we always want to go back to how the problem started before we did anything. Plug it into there. So I'm plugging a 6. 3 times 6 is 18. 18 minus 2 is 16. Square root of 16 is 4. 4 equals 4. We're good to go. Now the reason why it's a possibility that we just get a bogus answer is because of that first step we did. We squared both sides. This is clearly wrong. 11 is not equal to negative 11. But if I square both sides, what do I get? I get 121 and 121. That looks right to me. So what we're doing when we're squaring both sides, we have to do that to get rid of the radical, but we're possibly covering up a scenario like this. So that's why we have to check at the end, just to make sure that that wasn't happening. Okay? Let's look at another example. Okay, so first thing we got to do, isolate that radical. All that means is add the 2x. So we have square root of 9x minus 2 equals 2x. Once we get that radical isolated, same thing we had on the other problem, square both sides. So I'm going to square and square. This simply drops out. Nothing much to do there. And here be careful because we're squaring the 2x. So 2x times 2x is 4x squared. Okay? Now remember, whenever we have a quadratic come up in equations, we need to get a 0 on one side. When we get into chapter 11, sometimes those quadratics will not be factorable. We'll talk about how to handle that at that moment. Okay? Right now, if it's a quadratic, it will be a factorable quadratic. So I'm going to subtract the 9x and add the 2. So we get that 0 on the left, and then everything else on the right. Okay, now you might be thinking, why didn't you just bring that 4x squared over? when we get into the factoring is a lot easier when the x squared term is positive. Okay, it's not that it's impossible when it's negative, it's just easier when it's positive. So I like to set it up so the x squared term ends up positive. Okay, now, when we factor this with some guess and check, we could go with 1 and 4 or 2 and 2, and this is a 1 and a 2. That's it. Now think a little bit about this. We've got a 9, okay? If we have a 4 in the mix, a 4 times 2 is 8, which is really close to 9, isn't it? So let's try with 4 and 1. And then I'm going to go with a 1 and a 2. Okay, that gives me a -8, -1, there's your -9. Now if you're like, well, I would have gone with 2 and 2 first. That's okay. The worst thing you can do is just freeze and not do anything. Okay, if you guess the wrong thing, no big deal. That's why it's guess and check. Okay, but if you can think ahead a little bit and you can jump right into it, that's what we want to strive for. But don't feel like you don't know what you're doing or you're not good at this if you have to guess a couple things first. That's okay, that's part of the process. Now, when we have this, we set each of these equal to 0. So here I would add the 1 and then divide by 4. Here I would add the 2. Oops. And I have my 2 answers. Now again, I need to check both of them. Okay, it's possible they both work. It's possible only one works. It's possible neither of them work. So check them both individually. Go back to the original form, which is right here. Okay, if you want to plug all that in the calculator, go ahead. But if you're trying to get better at your mental math, this is the good place to practice. So I'm going to start with a 2. 9 times 2 is 18. 18 minus 2 is 16. Square root of 16 is 4. And then 2 times 2 is 4. So 4 minus 4, there's your 0. So this answer is good. We still have to check that though. Okay? Write down as much or as little as you need. Okay? But even if you're trying to do it in your head, sometimes writing it gets it a little bit better. It gets you a little bit better at doing it in your head. So if I go with 9 times 1/4 minus 2 minus 2 times 1/4. I want to make sure all of this gets to a 0. So 9 times 1/4 is 9/4. Minus this 2, I want to write in terms of fourths. So that's 8/4. Okay, this is, you're multiplying that. 9/4 minus 8/4 is a 1/4. Square root of 1, square root of 4, there's your 1/2. We still have this though. So 2 times 1/4 is a 1/2. 1/2 minus 1/2, there's your 0. So both of those answers down here work. Okay? Again, if you want to pick up your calculator and do all that, that's fine, but just make sure you're checking your answers. Let's look at another one. Now this one's a little different because we have a cube root instead of a square root, but everything is going to flow and structure itself the same way. So first thing I want to do is isolate the radical. So I'm going to subtract a 2. And I get that. Now when I had a square root, I squared both sides. When I have a cube root, cube both sides. So I'm going to cube. So this drops out, and then I get a -1 here. Okay? And then to finish it off, add a 5, x equals 4. Okay? And that's it. Now, when you have an odd index, okay, you're not going to have that possibility of squaring over a negative. So it's not as necessary to check here, but I would just suggest check all of these, okay? Because what happens is when you think, oh, I don't have to check them all, then you don't check ones that you're supposed to be checking. So just check them all. It's a safer way of doing it. It doesn't take that long. It's just the best thing to be doing at that point. So I'm going to plug that 4 in. 4 minus 5 is -1. Cube root of -1 is -1. -1 plus 2, there's your 1. So this answer, perfectly fine. We keep it. Okay? Let's look at another one. Okay, so good thing about this is we already have that radical isolated. It's a square root, so we are going to square both sides. Dropping this out very nicely and easily. But this, don't just say x squared plus 9. Because when we square a binomial, remember, we need to think of this as x plus 3 times x plus 3. And we got x squared plus 3x plus 3x plus 9. Okay, that whole thing has to be multiplied out. Now, if you want, you can combine like terms first. And then we go after that 0 again because we have a quadratic. So I'm going to subtract a 9 and then subtract an x. So that gives me the 0, and we have that. Now, that's a good thing. When that constant goes away, we should be happy because look, this still needs to be factored, but there's no guess and check. It's GCF, and that's it. So I pull out that GCF of x, and we're left with this. Very easy to solve. I set x equal to 0. I set x plus 5 equal to 0. This is done. The next one, I have to subtract that 5. And we have those. Now again, we have to check both of them. I go back to the original form of this equation. And I need to plug into that. Now, I'm going to start with a 0. 9 plus 0 is 9. Square root of 9 is 3. So I have a 3 here. 0 plus 3, 3 here. We're good. This is a good answer. How about -5? 9 plus -5 is a 4. Square root of 4 is 2. -5 plus 3 is -2. Now, that's what we're looking for. We have a 2 and we have a -2. That's not going to work. That's garbage. But why would we have gotten that? Because 2 equal -2 is false, but 2 squared is 4. -2 squared is also 4. Okay? So when there's an answer that's just bogus, we didn't do anything wrong, it's just a bogus answer. Typically, it's going to be a result like that, where it's 2 equal -2 or 5 equal -5. If you're getting, 3 equals 17, then I would double check that because then it's a little bit more likely that you made a mistake and that there's something wrong with your process. But when you have something that's like a 2 and a -2, typically it was just a bogus answer. Okay? Let's look at another one. Okay. Now, this one's different because we have 2 different radicals within the same problem. Now, I always say isolate the radical, and I'm going to maintain that, but when we have 2 radicals, separate them. You don't want to, at this point in the game, square both sides. Imagine doing that. Imagine squaring that. Writing that out twice and doing all that foiling. That would be a mess. Not that that's wrong, it would just be very messy. Okay? So what I suggest is when you have more than one radical, separate them. So I am going to subtract the square root of 3x. So I have the square root of 3x plus 1 equals 2 minus the square root of 3x. So I separated them. Now I want to square both sides, because then when I square this, that just comes out very nicely. I don't have to mess with that. This side, though, I have to mess with a little bit. When I square that, I need to think about that as 2 minus the square root of x, the square root of 3x, times 2 minus the square root of 3x. Okay? Now, take that slow. I'm just foiling. 2 times 2 is 4. Positive 2 times negative root 3x is a negative 2 root 3x. Here, I get negative 2 root 3x. And then here, negative times negative is a positive. Square root of 3x times square root of 3x just drops out that 3x. Okay? Again, if at any point you need to pause this video and look over what I just did, please feel free to do so. Or rewind, come back, do what you need to do. Now, I'm going to combine this up a little bit. So I got 3x plus 1 equals, I'm going to have a 4. I'm going to have this plus 3x. And then to pull all this together, I simply have negative 4 square root of 3x. Okay? Now, look at what all that did. Okay, that didn't eliminate my radical, but it did eliminate one of them. Now, I started by separating, squaring both sides, and this remaining radical I can now isolate. So I am going to then subtract a 4 and then subtract 3x. So those are gone. That's gone. I get negative 3 equals negative 4 square root of 3x. Now some people like to square both sides right now, and you can do that by all means. I personally like, before I do that, to fully isolate the radical by dividing by a negative 4. Okay, and that gives me 3 over 4, because 2 negatives make a positive, equals square root of 3x. Now I can square both sides. So I'm going to square. I'm going to come up here, and I get 9 over 16 equals 3x. Okay, because 3 squared, 4 squared gives me this. Squaring that square root of 3x is just a plain old 3x. Now, I could divide by a 3, but since I have a fraction involved, I'm not going to divide by 3. I'm going to multiply by a 1/3. It's the same thing as dividing by a 3. And now 3 and 9 reduce, so I get 3 over 16. And that's it. Okay, I get 3 over 16. There's your answer. Now, again, you need to then plug that in. Make sure you're getting that 2 that we have on this side. Okay, let's run through that really quick. We're going to have square root of 3 times 3 over 16 plus 1 plus square root of 3 times 3 over 16. Now that should all equal just a nice clean 2. This gives us 9 over 16 plus 1, which is 16 over 16, plus square root of 9 over 16. 9 plus 16 is 25 over 16. And then very nice perfect squares. Square root of 25, square root of 16, square root of 9, square root of 16. 5 plus 3 is 8. 8 divided by 4, there's your 2. Okay? So this answer works. We're good to go. Now, that concludes the examples for just solving radical equations. Okay? As you saw, it's very simple structure. You just isolate the radical, square both sides, and so on. But there are a lot of algebraic manipulations going on. So again, take your time. After you do a step, check it over. do a step, check it over. Because sometimes it's as simple as you write a plus instead of a minus, and then all that work is wasted because of that little mistake. Okay? So let's now finish up and move on to some word problem applications. Now, like I said, some of the problems in here are, here's a formula, plug and chug. Okay? I'm going to leave those up to you. If you do have questions, though, please reach out to me and I will help you through it. What I want to take the time to do here is I want to talk about Pythagorean theorem. Okay? Just a quick review, and then we'll look at a couple examples. Okay, now Pythagorean theorem is always going to apply to right triangles. A triangle with a right angle in it. Okay, the Pythagorean theorem that we all should be remembering from the past is that a squared plus b squared equals c squared. Now, the different parts of a right triangle are the hypotenuse and then two legs. The hypotenuse is always either going to be identified as the longest side or the side opposite the right angle. That's going to be true always, but you can identify it as one of those two things. Either the longest side or the side opposite that right angle. The hypotenuse will always be our C value. The legs are the two sides that are forming that right angle. Which of those legs is A, which of them is B, does not matter, because you're adding. So we have that commutative property. Okay, so I could call this A, this B, or this B, this A, doesn't matter. As long as the hypotenuse is C, we're good. Okay, now, first thing that they would throw at you is simply something like this. Here's a right triangle. Find that missing side. Okay, now when we're doing that, we would first write out that Pythagorean theorem. Whenever you're using a formula, write it out. Okay? That helps you keep structure to your problem, and it helps you remember that formula. Now, let's fill in what we know and what we need to find. So this x and this 6 are making that right angle. Those are your legs. So I'm going to go with x squared plus 6 squared equals that hypotenuse of 9 squared. If you put 6 squared plus x squared, totally fine. Then I get x squared plus 36 equals 81. I subtract the 36. (81 minus 30 is 51. 51 minus that extra 6 is 45. And then to finish this off, all I do is take the square root of both sides. We're going to delve a little deeper into that move right there when we get into the beginning of chapter 11. But right now, it's Pythagorean theorem, just square root, I get an x. Now that root 45, if they tell you to round, you plug that in the calculator, you get the decimal. Okay? However, if they don't, always leave it exact but simplified. So 45, I'm going to think of as a 9 times 5, or a 3 root 5. And there's your missing side length. It's as simple as that. Just plug and chug. Now let's look at an actual kind of application that involves a right triangle. Okay? I am looking at practice 7 that is found on page 638, and it reads, Keith Robinson bought 2 Siamese fighting fish, but when he got home he found he only had one rectangular tank that was 12 inches long, 7 inches wide, and 5 inches deep. Since the fish must be kept separated, he needed to insert a plastic divider in the diagonal of the tank. He already has a piece that is 5 inches in one dimension. He already has one piece that is 5 inches in one dimension, but how long must it be to fit corner to corner in the tank? So what he has is a single rectangular tank. So it would be something like this. Okay? So what he needs to do is basically make two tanks out of this one. What he plans to do is take a piece of plastic and insert it like so. Okay, along that diagonal. So if you had a bird's eye view into this tank, you would have the rectangular top and you would have that piece of plastic doing something like that. Okay? Now, they tell us that this tank is 12 inches long, 7 inches wide, 5 inches deep. So it's 12 inches, 7 inches, 5 inches deep. He has a piece of plastic that's already 5 inches, so we don't have to worry about the depth. So all we have to worry about is this two-dimensional representation right here. We know that it was 12 inches. We know that it's 7 inches. We need to know how long that piece needs to be. And as you can see, yes, we have this three-dimensional tank, but it really just comes down to that triangle. Okay? So let's work that out. Again, we have a squared plus b squared equals c squared. That's 7 squared plus 12 squared equals c squared. That's 49 plus 144. And then again, if you need, you can do this, okay? But you've got c squared equals 193. Okay? Now, when you have that c squared equals 193, we're not done. We need to finish it up by taking the square root on both sides. Okay? Now, if I don't say round, I would want that exact but simplified. Now, that's an exact value right there, but is it simplified? Don't look at that and say, I hope so. Okay? If you have to, then you dig in and you try to see if any perfect square goes into that. Okay, that doesn't mean you have to do it all in your head. Again, if that means you need to pick up your calculator, pick it up. I'm not going to divide that. I'm not going to see if this divides by 2 or 3. I'm going to look at the perfect squares. Okay, so I would just take 193 divided by 4. Doesn't work. Okay, and I shouldn't even have to plug that in because this is an odd number. 4 is not going to work. It's an even number. It's not going to divide. Okay, but that's 2 squared is 4. 3 squared is 9. 193 divided by 9. Not going to work. 193 divided by 16. Not going to work. 193 divided by 25. I'm going through all the perfect squares. Okay, none of them are going to work. This is as exact as I can make it. There's the length I need for that piece of plastic. Okay. So again, the applications they show you in this section are all either going to be, here's a formula, plug and chug, or use that Pythagorean theorem on a right triangle. Okay? So, as always, keep working hard. Let me know if you have any questions, and I'll see you next time.